Hello, we are going to prove a quadrilateral is a trapezoid now on our coordinate plane. So in order to prove that a quadrilateral is a trapezoid, we have to show that one pair of sides are parallel, which means that they have the same slope, and one pair of sides are not parallel. They have different slopes. Then, if we want to prove that the quadrilateral is an isosceles trapezoid, first we have to prove that it's a trapezoid by doing the steps up here. And then we can choose one of the two methods. We can either prove that the diagonals are congruent using distance formula, or we can prove that the pair of non-parallel sides are equal. So here's our example. It says prove quadrilateral milk, M-I-L-K, with vertices 1, 3, -1, -2, and 4, 3 is an isosceles trapezoid. So that means that I have to prove that it's a trapezoid, then I have to prove it's an isosceles. So let's go ahead and draw what we have. We have M is at 1, 3. I is at -1, 1. L is at -1, -2. Oops, that's not. -1, -2 is down here. I'm sorry. And K is at 4, 3. And I'm not sure. Of course, with my drawing, it's hard to tell, right? So we cannot rely on our drawings. Hopefully you are better at drawing a straight line than I am when it comes to using my finger on this whiteboard. But let's continue on. And so let's go back to the rule. So first we have to show that one pair of sides are parallel and one pair are not parallel. So looks like we'll look at this pair. So from, and I can't even read my, let me do this better. So it's not too much better, but at least I can tell my different points now. So I'm going to look at MI and KL. So MI and KL will find the slope. So slope formula is Y2. So we'll say, since we have MI, we'll say I is my second. So Y2, which is 1, minus Y1, which is 3, divided by X2, which is -1, minus X1, which is 1. And that gives me -2 over -2, which is +1. So next we'll do KL. So the slope of KL. And so we'll KL, and we'll say L is our second point. So that is Y2, which is -2, minus Y1, which is 3, over, and by the way, just in case you don't remember, slope is the change in Y over the change in X, or Y2 minus Y1 over X2 over X1, or rise over run. Any of those will work. All right. And then we have X2, which is -1, minus X1, which is 4. And so that gives me -5 over -5, which is 1. So we showed that these two are parallel. All right, so now we have to show that these two sides are not parallel. So let's do that. So we'll do IL. So L will be my second point. So that is y2, which is negative 2, minus y1, which is 1, over x1, which is negative 1, minus x1, which is also negative 1. So that's a negative minus, negative 1 minus a minus, which turns into a plus. So I get negative 2 minus 1, which is negative 3, over 0. So that's 0. So we did IL, let's do MK. Alright, so K is my second. So that is y2 is 3 minus y1, which is 3, over x2, which is 4, minus x1, which is 1, and that gives me 0 over negative 3. And I'm sorry, I did this backwards. Please forgive me for this mistake. This is undefined. I can't divide by 0. So that's actually undefined. And I can have 0 divided by, that is 0. So negative 3 divided by 0 is not 0, it is undefined. And 0 divided by negative 3 is 0. So this side is not parallel. So we just proved. So it says show that one pair are parallel and one pair are not parallel, so different slopes. So this is a trapezoid. So now we have to prove that it's an isosceles trapezoid. And so we can choose one of these sides. We can either look at the diagonals or we can look at the pair of non-parallel sides to see if they're equal distance. Let's do 2, because we have in the previous videos I looked at the diagonals a lot, so let's look at the sides and see if they're equal. So we're going to use the distance formula. So of course I need to erase everything that I have here so far because I don't have enough room. Okay, and I went ahead and put the distance formula up there just for our memory. So distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So we need to find the distance of Li first to see if it's equal to MK, because those were the sides that were not parallel. So we'll do that. So let's say the distance of IL, and since we named it IL, L will be our second point when we're referencing. So L, second point, negative 1 minus a negative 1 squared plus negative 2 minus 1 squared. So negative 1 minus a negative 1 is negative 1 plus 1, which is 0. So I'm just going to go ahead and cross that out. We don't need that anymore. Then negative 1 minus 1 is, and so since I did that, oops, this is not going to have to be that big. Negative 1 minus 1 is negative 3. Negative 3 squared is 9. The square root of 9 is 3. Okay, now let's do MK. Alright, so K is our second point because we wrote it second, so we'll choose that to be our second point. So we'll say 4 minus 1 squared plus 3 minus 3 squared. Again, I get 0. 3 minus 3 is 0, so we don't even need that part. And 4 minus 1 is 3. And we already know that 3 squared is 9. And the square root of 9 is 3. So it works out. It checks out. They are congruent, so that means this is an isosceles trapezoid. And I hope that this helps.